The t-distribution can be used for estimation. We can use a t-table or technology such as StatCrunch to find values of a specific t-distribution. In other words, when the degrees of freedom is n minus 1 for a given sample size, in order to bound the middle 90%, 95%, 98 or 99% of t-scores. We can then develop a confidence interval estimate for an unknown parameter mu. The resulting formula is that we start with the sample mean y bar, subtract the critical point t, which is based on the confidence level and the degrees of freedom, and then multiply by the standard deviation or standard error, which is the sample standard deviation s divided by the square root of n. So y bar minus the t times s over square root of n is the lower limit, and y bar plus the t-score times s divided by the square root of n is the upper limit for the confidence interval. So if you look at the formula in detail, y bar plus or minus t based on some number of degrees of freedom and confidence level times s over the square root of n can be broken down where y bar, the first part, is the point estimate. Okay, it's your single point, your single number that is your starting point or your best guess at the parameter, in this case the population mean, which we want to estimate. The entire part after the plus and minus, the t sub df times s over the square root of n, that entire part is called the margin of error. It consists of two pieces. T sub df is called the critical point. It's the value such that the portion of all t-scores from the student t-distribution for the degrees of freedom is bound between the negative t-score and the positive t-score. It bounds that central 90% or 95%, for example. The remaining fraction, the s over the square root of n, is the standard deviation or the standard error of the mean. Now what it does is says how spread out or how much variability is there in the y bar distribution. So what you're going to do is essentially untransform from the t-distribution where you bound the middle 90% or whatever of values back into the original domain. Suppose we need to find a t-score from a table. To find the appropriate value of the t critical point, the t sub df value, to correctly estimate the population mean, we must use a table or technology. So if we're using a table, we want to calculate the degrees of freedom. And remember, df is n minus 1. Look for that appropriate row in table T. If there's not a value there that exactly matches, typically to be safe or to be conservative, we use a smaller value. Then look under the column with the appropriate level of confidence. Now what you're going to have to do is look at the two-tail probability row, which gives you the total alpha value in both the left and right tails. So 1 minus alpha times 100 would give you the percent level for confidence. Let's look at an example. Suppose we wish to estimate the mean utility bill for all Northern Kentucky residents during the summer. A random sample of 55 residents yields a mean of $108 with a standard deviation of $18. Estimate the mean bill for all residents using 90% confidence. What parts of the confidence interval formula are provided and what needs to be found? Specifically, what do 55, $108, $18, and 90% tell you? Okay, let's start with the critical point here. So to find the critical point, we need to calculate the degrees of freedom, which is n minus 1. So that's the sample size of 55 minus 1, or 54. So t sub 54 is our desired number. Now from the partial table below, what we would do is use df equal to 50 because 54 is not in our table. Okay, so t sub 50, I want to look in the row where degrees of freedom is 50. In the column, now for 90% confidence, the alpha value in two tails is going to be 0.2. So the two-tail probability, the 0.10 column, and the 50 degree of freedom line gives me a critical point, or a t-score, of 1.676. So the t-score to use is 1.676. Y bar, the sample mean, is $108. S, the sample standard deviation, is $18, and the sample size is n equal to 55. So using our formula, y bar plus or minus t sub df times s divided by the square root of n equals 108 plus or minus 1.676 times 18 divided by the square root of 55. That equals 108 plus or minus the margin of error of the estimate of 4.067852, and then if I round off to the hundredths digit, I get $103.93 to $112.07. So my summary sentence might be reported as, at the 90% level of confidence, we estimate that the mean utility bill among all Northern Kentucky residents during the summer is between $103.93 and $112.07. Notice the margin of error of the estimate, the part after the plus or minus, is the $4 and then 0.067852 of another dollar. Is the confidence interval valid? Let's go back and check. A random sample of bill amounts, which is quantitative data, was selected. The population standard deviation, sigma, is unknown, so we used the sample standard deviation, S, which was $18. And n equal to 55 meets my at least 30 requirement. So yes, this interval is valid.